These are called exponential equations. They're called exponential equations because what we're solving for, which is x, is in the exponent. Now, over the course of this unit, we're going to learn different techniques for solving exponential equations. The first technique that we're going to use, and we're going to use for solving today, is going to be using our powers chart, and our goal is to get both sides as a power with the same base. So that's going to be our goal. Can we get both sides of our equation to be a power of the same base? If we can do that, right? If we can do that, things are going to be easy to solve for. So we're going to see that in example 1. Example 1, I have 4 to the x equals 1 over 256. So looking at the numbers in this question, we're going to say, can we write these as a power with the same base? And we might go back to our powers chart as a result and say, are the numbers 4 and 256 ever in the same column? And it actually happens more than once. In the powers of 4, we have 4 and 256. And in the powers of 2, we have 4 and 256. So you could change both of them to powers of 2 or change both of them to powers of 4. So what does that look like? Well, since this one's already a power of 4, I'm going to change the 256 to a power of 4. 256 is 4 to the power of 4. Now, our goal is to get both sides as a power with the same base. We're close. The left-hand side is a power with a base of 4. The right-hand side is 1 over a power with a base of 4. We would like to get the right-hand side also as 4 to the something. And so this is where we're going to use our exponent laws and our exponent rules. Is there another way I can write 1 over 4 to the 4? If it's negative. So then it would become 4 to the negative 4. And once we've written our powers with the same base, if these are equal, 4 to the x equals 4 to the negative 4, what does x have to be? Well, if they're equal, does it make sense that 4 to something equals 4 to something? Those somethings would have to be the same. And so once we get the bases the same, we can basically say, so as a result, we're not doing anything mathematically here other than observation. If these are the same, x has to equal minus 4. That's the only thing that's possible. If x is anything else, they won't be equal. So looking at part B, in part B we have 27 to the x equals 9 to the 2x minus 1. So our goal is to try to get them as powers with the same base. Right now, the one side has a base of 27, the other side has a base of 9. So we think, on our powers chart, is there a way of writing 27 and 9 both with the same base? And what would that base be? What column does that happen in? So I'm going to rewrite 9 and 27. 27 is what to the what? And 9 is what to the what? Do I need to go back to the powers chart? Or can you see it? 27 is 3 cubed. Good. And 9, 3 squared. So we need to get those with the same base. And now we get back to our exponent rules. I want to write a single power on both sides. On the left side, I have a power to a power. On the right side, I have a power to another exponent. What is my exponent law for this? Do I add, subtract, multiply, guess? I don't think there's a law that says guess. If you don't remember, go back to simpler numbers, right? What happens if I had 2 squared cubed? What would that mean? And then don't just go to a rule. Think about, what does it mean? What does 2 squared mean? 2 squared means 2 times 2. What does something cubed mean? It means the same thing multiplied 3 times. If we go back to the meaning of what things are, how many 2's are there going to be in the end? All multiplied together? 6 of them. So what's the rule for a power to a power? Add, subtract, multiply? Multiply. And if it works for the simple numbers, that means when we get to here, power to a power, we're going to need to multiply. And same thing here, power to a power, we're going to need to multiply. And how do you multiply 2 times 2x minus 1? You're going to need to distribute. And now we have succeeded in getting the bases the same. And we have a single power on both sides. So I like to take out a different color pen and say, well, if the bases are the same and the equations are the same, the exponents must be the same. So because of that, I know that 3x has to equal 4x minus 2. And unlike the first one that we did where we got x right away, now we still have a little bit of algebra to do. Got to bring our x's to one side. I think I'd bring my x's to this side to just get x. Move my 2 over to this side. And I get x is equal to 2. So all of our exponent laws are going to come back into play. Along with this process, can we get both sides to be a power with the same base, then we can solve an exponential equation. So I'd like you to practice this right now. 3, 4, 5, and 6.